Hello everyone, my name is Sanjeev and I am from the T01 group, and along with Vignesh, Mohan, Mrunal, Salvi and Srikanth, Kamath, we are doing a statistical analysis of various cloud services to figure out which service is better and in which use case. So we try to collect statistical analysis of various cloud services and get various metrics from it and try to compare the pros and cons of each of them to figure out which one to use in which scenarios. So before we go into the presentation, I'll show you the data we collected. We ran a test on a tool called Cloud Harmony and Geekbench, and we plotted it on a Google Sheet. And we did a region analysis mainly to compare performance from various regions. Like we have North America, and in each region we have a CDN test, a cloud storage test, a VM test, and a DNS query test. So you have North America, Central America, South America, Europe, Asia, and so on. US West, US East, US Central. And for each region, we calculated a mean of the time it took, the median, the 90th percentile, the 75th percentile, the 25th percentile, the 10th percentile, the fastest time, the slowest time, the number of tests performed, the number of tests that successfully went through, the number of tests that failed, and the uptime for each of them. So let's look at the presentation. So we have a lot of GQM metrics and the critical tracking metrics, and the domain analysis we did, we found out that the top three cloud providers are pretty much in a league of their own, being Amazon AWS, Google Cloud, and Microsoft Azure. We have some others too, like IBM Cloud or Alibaba, and Oracle VM, but they're pretty far behind with respect to these top three. So we have a lot of things on what each of them give and what the costs are and what features they give, and you can have a look at all these. We'll be submitting this. So we'll move on to the test that we actually ran. So we ran a network performance analysis using a tool called Cloud Harmony, and as I showed you the data points before, uh, it uses a RIPE Atlas Internet Measurement Network for testing network performance metrics, and it mainly runs two tests, one being the DNS query and the two being a latency test. And we try to gather data for all data center regions because we understand that some may be more faster in North America, but it may not be as fast in Asia. So we thought it was important to compare it globally and find out which one's better in which area and which one is better globally. So this is what we saw in the Google Sheet, and so for North America, the city network performance, you can see that the x-axis is the various metrics, and the y-axis being the time it took in milliseconds. So a lower value is better, and we have a lot of these. So I'll just quickly go through this, and I'll just talk about the analysis for North America. We have Google being the fastest the first three, and Amazon S3 being the fastest in DNS query. And for Central America, again, we have Google being the fastest, with Azure also being equally tied for cloud storage, and Azure being the fastest DNS query. And for South America, we have Google being the fastest for the top first three, and Amazon AC2 being tied with Google for VM, and the fastest DNS query being a tie between Amazon S3 and Azure DNS. And for Europe, we have Google being the fastest for the first three, and almost equal for the DNS query time. And for Asia, we have Google being the fastest for the first three, and Azure being the fastest DNS. And for Africa, we have Google being the fastest for the first two, and the second one being tie between Google and Azure storage, and the fastest being VM being from Azure, and the fastest DNS query pretty much being a tie between all three. And for US West, we have Google being the fastest for the first two, with Azure being tied with Google in terms of CDN performance, and the tie between all three for VM performance, and Amazon root S3 being the fastest for DNS. And for US Central, we have almost equal for the fastest CDN, and Google being the fastest for the cloud storage and VM, and Azure being tied with Google for VM performance, and the fastest DNS query being Amazon S3. And for US East, we have the fastest being a tie between Google Cloud and Azure CDN for the CDN, and the fastest cloud being Google Cloud, and the fastest VM being a tie between Google Compute and Azure VM, and the fastest DNS being Azure DNS. So as a whole, you can see that even though Amazon AWS has a wider infrastructure and it entered into the cloud market before Azure or Google, and it probably has more establishments and more features, but it still lags behind in terms of like performance and compared to Google or even sometimes Azure. So overall, it seems that Google is better in terms of performance overall. So the second test we did was a DNS test, and for this we used a tool called Geekbench. And to keep it even across all three cloud providers, we use the same base configuration for all three cloud providers, being a processor of Intel Xeon, and we used a multi-core with 2 cores and a base frequency of 2 gigahertz of processing power. So tests we ran were text compression, image compression, HTML5, SQLite, PDF rendering, text rendering, speech recognition, and machine learning. So we tried to like figure out how much time it took for each of these tasks to run on all three cloud providers to figure out which one to use in which scenario. So let's quickly go through this. For text compression, before we run into this, so the x-axis is the various cloud providers and the y-axis being the Geekbench score provided, and the score is provided based on the average time in text. So a higher score is better in the scenario. So you can see here that it's pretty much the same, but Amazon VM had a slightly better single core performance, and Amazon EC2 has a better multi-core performance. And for image compression, you can see that Amazon EC2 easily outperforms both its competitors. And for HTML5, it's pretty much the same for all three. It's almost identical, but Google Cloud is slightly higher in terms of multi-core. And for SQLite, almost equal performance in the single core department, and EC2 and Google have better multi-core performance than Azure VM on SQLite. And for PDF rendering, Amazon EC2 has a better single core performance, and EC2 and Google Compute have better multi-core performance than Azure VM while rendering PDFs. And for text rendering, we have EC2 having a better single core performance and also having a better multi-core performance, way better than the other two. And for speech recognition, we have Google Compute Engines. For speech recognition, we have Azure and EC2 being pretty much the same, but Google Compute Engine pretty much underperforms in this test. And we have Azure VM leading with the single core performance and EC2 leading with the multi-core performance. And for machine learning, we have EC2 being the fastest for single core and also EC2 being the fastest for multi-core. So overall, you can see that even compared to the DNS queries, for in terms of real-world applications, you can see that Amazon EC2 does fairly well compared to the other two. Even though it's mostly similar, you can see that Amazon EC2 does better in terms of single core and multi-core performance in terms of real-world applications. So this is a plot of the time it takes to train a machine learning model versus the cost. And obviously, you want to have it in the bottom left corner if possible, having training a model in as low as time as possible with as low cost as possible. So look, the main outliers are Amazon AWS EC2 having a really high cost to train, and Google Colab having a really long time to train. And the best ones seem to be from Google Compute, having a low cost and low time to train it. So some of the generic risk involved in this project for when you're using a cloud service provider are like loss of theft or intellectual property, and loss of control over end user actions and malware infections, diminished customer trust, data breach notifications to victims, and being data deletion being incomplete and increased complexity. So these are risks more about like when you use a cloud service, what are the risks involved with it. But in terms of risk for us in this project on collecting all this data, it was mainly about keeping the cost to the minimum because we used a free student tier for running all our tests, and using a paid tier is probably a bit too expensive. So and when you're using a free tier, you have a certain limit which you can't go over, and if you do, you get automatically charged. So the main challenge for us was to keep our compute power within the limits so we don't get charged. And yep, that's pretty much it. We have the references here, and yep, thank you for listening.